Hi, good morning. Welcome back. Today, as daily, we have to find a subarray of length k, where all the elements are distinct, and we have to report the maximum sum. I saw a lot of people like going crazy over this problem that they need to optimize this. Yes, if you want a zero ms problem, then obviously you have to do some like I don't know, voodoo magic or something like that. But it's not that tough of a problem when you understand that it's just like a sliding on problem. So like if just taking this, I would say like just see what I'm doing right now. Like, and this is why I believe that you should not be going upon anyone's opinion regarding a problem, whether the problem is hard, easy, or whatever. Like this is fairly easy, straightforward problem which you can ace it like in less than 2 minutes or 3 minutes. It's like no brainer problems. So here what I have, like an array 1542999, and I have to find 3, right? Like the sliding window length is 3. Now just for the moment, uh, ignore this. So obviously I have told in a previous video that if the length of an array is n and the sliding window like subarrays length is k, then the total number of subarrays will be n minus k plus 1, which is in this case 3, 4 and 7. So 7 minus 3 plus 1, that is 5 subarrays. 1, 2, 3, 4, 5. What we have, right? So, but we have a condition boundary that every element in a subarray should be distinct. So let's write all the subarrays: 154, 542, 429, 299, and 999. Now we can see that here every element is distinct. Here also we have number of distinct element. Here we have two elements and have one element. So these and these are not actually our answer. Our answer is only these three. This sums to 10, this sums to 11, and this sums to 50, which is our maximum. Now, how to approach this? This is like a fairly simple problem. Just if you know how to like iterate through subarrays, you will do it very easily. What you have to do is like assume this is an array. Like let's say we are finding maximum sub array sum, but of length k. Like if this won't be there, the condition, then this is just a dance algorithm. But if there's a restriction of length k, then this is like straightforward problem, like very easy. First we will go to first k elements, like what we have here, 154,249. So 154,299 and 9, right? So first we'll go this, right? Now we'll store the sum here. Like let's say we have a square sum, which is sum of first k elements, which is 10, right? And I'm assuming max sum is minus 1 here. Now I've calculated this, so I'll just update this. So if like it all distinct, now how, what is the best measure to store all distinct? You can use set, you can use multi-set or map. These two needs implementation. Like you have to kind of think how to implement it in proper way. This is what I love. I love simple things. Map is the best choice here. Now let me tell you how. So assume, yeah, so assume this is my map, and this is my map. Here I have element, and so when I'm storing the sum, like let's say 4502K, I'm I am writing C sum plus is equal to norms of I, and then I'm also adding here. So my 1 goes one time, 5 goes one times, 4 goes one times. But the map size of my map, it's 3. Was the length of the distinct element should be, like, sorry, length of the subarray and all the distinct elements, so it is 3 is equal to 3. So my maximum sum, I can update maximum sum so far, which is 10, right? Now obviously if we shift this here, then we're removing this and adding this. Then for next iteration, it should be k minus 1. It will go from 0 to, no, it will, yes, it will 0 to k minus 1, because it's 0 based index. Now it will start from k and it will go to n minus 1. So I'll put a pointer here, like I'll drop a pointer here, and then I'll move from here. So what I'll do, I'll add this, and I'll just do this same thing, but I'll be removing what I have, but I have like used so far. I don't use it now. Like, I don't want to overcount it. So first of all, I'll remove the left part, that is 1. So now my left has become 0. I have add the new element to the window, which is 2. So now my 2 is added once. Now if you can see, the size is still 4, right? But this element is just present here, it's not included in the window. So we have to remove this. So I'll check if MP of left is 0, like it has 0 values, that is, it has appeared in my window 0 times. I'll just remove that. MP dot erase nums of left. Just now I'll remove this. This is my new map. Now window is shifted here. I'll add 9, remove 5. But we have not updated the sum. That I can show you, like 5, 4, 9 plus 2, 11. So the sum would be updated just like the map. I'll add the right element and subtract the, sorry, it should be nums of left. Nums of left. And if my map size is equal to k, that is every element in this window is distinct, then max sum is max of sum and max sum. So here, that for this window, the 10 would become 11, and for this window it will become 50. Now I'll add 9 here, which is 2 times, and remove 4. So this 2 will be removed, but now my window size is 2, so this condition won't update. Now again I'll remove 2, or like I'm talking about this window and this room. Still my window size is not k, so our final sum max would be 15, and 15 is my answer. One thing you can do, like instead of using map, like if you want like a 1 ms 0 ms solution, then you can maintain a counter that would denote the number of dupli- duplicates, and that is only possible because the maximum element is 25. Like this is the hint that interviewer might give you, that the element is 25. Now you have to like um, use this as like optimize this as much as you can, because right now the complexity of this problem is like time complexity is O of and log n is like the loop I'm traversing, and login operation denotes the map operation. But you can just nullify this. This login can be converted to constant time because it's 25. You can create an array of 25, and those lookup operation would be uh, O1. But then the tricky part comes: how would you like implement the size of window? Like how would you uh, know that how many elements to have? So that is, I wouldn't say fairly easy, but obviously you can, if like try and dry run for 5 minutes, you can understand that what I'm talking about. If you wanna do it, you feel free to know, just pause the video and go and try to implement it OFM, sorry. If not, then you can enjoy the party. So let's say I make a function of push, like or I could just add right, and another function of remove, right? And initially my this counter would be like, let's assume d for duplicates would be 0. Now what I will do, I'll initialize an array of 185 plus 10, just like maximum size, so isn't taking. Whenever I am adding an element, like I'm adding an element, what I'll do that I'll increase the sum with that element, let's say X, right? And I'll check that if, and obviously I'm adding, then I'll increase the count. Initially, well, all the element would be 0. Every index has a value 0. I'll just increment the frequency of that number. If I'll check if array of X is equal to 2 or greater than 1, basically, then make it increment at d, and the same in the remove section, that sum would be minus of X this, and if not, like it is 0, then d minus X. Okay, Now how it will work, like what I'm talking about. So the nums array we had was 1, so 5, 4, 2, 9, 9 and 9, right? Initially my counter is 0, add 5. My sum has become 5. Now I'm just making a small counter like for 1, 2, 3, or better to make it inside of the board. 1, 2, 3, 4, 5. Or just take the elements that I have told while I'm adding everything. 2, 4, 5, and 9. So I added 5, 1. That one duplicates counter is not greater than 1, right? So it's still 0. 4 and 1, the sum has become 9. 2, 1, the sum has become 11. Cool. Now I have done for the scenario, like I'm done with this part. Now I'm coming here, like from next. Now I'll add 9, 1, and then I'll remove 2, sorry 5. So 11 plus 9, it is 20, 20 minus 5. But if you can like see, the D is still 0 because nothing has exceeded 15. So my max sum has become 15. I'll give you a pseudocode for this, but I'm just trying to explain in a like very descriptive way. But now if I add is I have removed 5. 5 has become 0. If I'll add 9, right? So this will be 2, which is greater than 1. So my is 1. So D is not 0 here. You can see D is not 0 here. So this array has the sum would not update here. Now again 9 has become 3, removing this, still this has become 2, which is greater than 1. It should be greater than 0, which is greater than 1. So no, it would be 1. Okay, see if also have to be have 1. So this would not like now this array would update this and not this. So this would give you a 1 complicate. I'll try to implement both of them, but this was the fairly, like I would say, most efficient solution for this problem. Okay, let's implement it. Take a sum 0 and max sum also. I'll try to make it into so that I'll look as a return 0. So if everything happens and max sum is still increment, then return 0 and max sum. We need a map, make it hash. This is k and sum plus is equal to nums of I, hash of nums of I added. Now if hash dot size is equal to the window, so that means every element I have in the window is a distinct one. So I'll update it. Fine. Now I'll put initial left pointer, right pointer. It would be at k. Yes. What I'll do first, I'll remove the left element and then add the right element. Same with the sum. Now what I we were checking that if hash of nums of left is equal to 0, then I should remove that from array, and then the same condition would be applied here, and we're done. Oh, it should be, it is. See, it passes, but it is quite slow, right? Now, what you can do to, uh, I would say, like, improve the time complexity, like make it on, I can make an hash array, all zeros, and duplicate count as 0. Void add, where I'll pass the element, where hash of x would be, and I'll pass the sum. Or I can actually initialize sum. And if and add this element to the if hash of x is greater than 1, then duplicate plus plus. Same with removal. Hash of x minus minus, sum minus is equal to x, and if hash of x is equal to 1, then do minus minus. Okay, so what we have here, the change. I'll first add element, because till k we're just adding, right? If duplicate is not 0, it should be 0 always, because I have no duplicates here. Maximum should be non-minimum, where the answer. Okay, max of sum and max of. Now that should be here. We need a left pointer. This will go to nums dot. I'll add the, then remove Okay, and then again the same condition. If this is true, update this. Let's see if it works or not. It doesn't. Why? Am I doing something wrong? I have to just add it here. I'm increasing this. And I'm increasing that actually. Then what's the problem? What could be the problem here? I'm adding this, implementing the duplicate. Should be there, right, left, right, over. But not removing the but printment doesn't here doesn't matter, because if it would have been a negative case, then it would have mattered. I can just remove intimate, but whatever. This should work. Yes. Sorry. Still runs on 168. Wow. 77. Good progress. So you can see that the solution has not become now have become purely one, and it works fine. Thank you. 99.963. Great.